Hi, my name is Richard Williams. I'm at the Mercatus Center at George Mason University in Virginia. And today what I want to talk about is regulations, and particularly regulations that are trying to prevent us from getting cancer. Excuse me. So every year we pass something like 3,000 to 4,000 regulations. And we now have regulations that provide instructions on the economy that has exceeded 1 million. That's 1 million different instructions to businesses and consumers that tell them what they have to do. And some of those regulations actually may be unnecessary. In fact, some of them might actually harm us. So let's just take a look at those regulations, particularly the ones that are designed to address cancer-causing substances. Normally, what you would think is more is better, right? Well, no, not actually. So let's see, how do we decide whether something causes cancer? For a start, we start usually with animals, rats and mice, and we test rats and mice by giving them doses, exposure to some of the things that we think might cause cancer. So for example, in the 1970s, we tested saccharin. Saccharin was a common sweetener in sodas back then, and we fed those rats the equivalent of about 800 cans of soda a day. So from those 800 cans of soda a day, we saw how many rats got cancer as opposed to those that weren't fed the 800 cans of soda a day. Then what we do is we look at the excess cancers and we say, well, okay, let's kind of extrapolate that back to humans who drank maybe 2 to 3 sodas a day. And so the point is, if you got something that caused cancer at 800 cans a day, you assume that that would cause a lot of cancers. If you only drank 2 to 3 sodas a day, that would cause a few cancers. Well, there's a lot of problems with that theory. One is it kind of ignores the basic principles of the science of poisons, which is called toxicology. And that science says everything's a poison. There's nothing that's not a poison. What makes it a poison is how much of it you get. And the right dose differentiates a poison and a remedy. And that's the key to what our problem is. So for example, think of things that you commonly consume. Aspirin. A few aspirin and your headache goes away. You take a lot of aspirin and it'll kill you. The same thing is true with water. Water is necessary for life. You drink enough water, it's good for you. You drink way too much water and you die. Same thing is true of salt and so many different substances. So the point we're trying to make is that for most compounds, a little bit of something either does you no harm at all or is good for you, but a lot of it will kill you. So here's another example. Most people know that pathogens, those little tiny little microbes, can make you sick, things like salmonella and listeria. You also may know that farm families don't tend to get as much food poisoning as ordinary people. Why is that? That's because they're exposed to lots of pathogens, particularly growing up. Those small doses of pathogens tend to immunize people as they get older, and so that they don't get, tend not to get food safety problems, particularly food safety illnesses. So what we've been finding out over the last several decades is there are lots of things like this. That, for example, everybody knows that radiation causes cancer, and that's true. A lot of radiation will cause cancer. But it turns out there's been studies that have been done for decades now that shows that small doses of radiation may actually protect you against cancer. For example, prostate cancer. So what does this have to do with the cans of soda that we talked about? What it means is that you can't just assume that if you are given a rat or a human a big dose of something that it will cause cancer, and that a little dose of something will just cause a little bit of cancer. As it turns out, a little bit of something, which can be a protective dose, and here's a new word, can cause hormesis, which is a protective effect, actually would be a good thing. So why is too much regulation a bad thing? Well, the point is, suppose you have, again, a substance like saccharin, and we're assuming that because we got cancer at high doses, we should regulate it all the way down to very small doses. If those small doses are in fact protective, and we regulate below those small doses, we're missing a protective effect. So many regulations now are becoming so stringent, regulating down to small doses, that the point is that we're missing protective effects. As of now, regulatory agencies, social regulatory agencies like EPA, FDA, USDA, haven't really taken into account these small protective effects, this hormetic effect. What we'd like to see is for them to start taking this into account when they go to figure out how stringent they should regulate all of the various compounds. And let's face it, at those high doses, when you test them, 50% of everything that you test turns out to be, quote unquote, a carcinogen, something that causes cancer. That's absolutely not true, and we're beginning to understand more and more about it. So, my hope is that agencies will begin to take this into account, and with any luck, this will be coming to an agency near you soon. Thank you.